Yo, 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 yo. Hey, everybody, this is Mr. G, and this is a video all about scale drawings. So let's first get into the key terms, and then we'll start doing some examples. So scale drawings, what they are, guys, is they are basically they're blueprints, okay? But the more specific definition is right here for you, and they are proportional two-dimensional drawings that are similar to an actual object. So they can be some type of drawing that represents an object that's really, really big, so we shrunk it down and drew it proportionally smaller to size. So like a blueprint of a building would be a scale drawing. They took if we look at DePaul Middle School, what they did is they took the whole school first before they actually built it, and they had it all on plans on a blueprint of some sort, and it was shrunk down to size, though, to scale, so that it was proportional to the real size. And then they can go from there. Or they can also make things larger. So when you guys look in your science books and you see atoms or molecules or anything like that, those are scale drawings. Now, the scale of a scale drawing is a ratio between the two sets of measurement. So this is what the scale is super important, because this is what we're going to use in order to solve our problems. So ratios, as some of you may know, mean they're really going to be set up as fractions. So in our scale drawings, every 2 inches in our drawing might be equivalent to maybe 3 feet in real life. Okay, and I'll show you an example of what I'm talking about right now. So here we have a scale drawing. Okay, so on the top right of the screen here we have a scale drawing. This is just somebody's, looks like a bedroom. Okay, so it's a blueprint of a bedroom. So this is when maybe this is a room in a house. Let's just call it that right now. Okay, the downstairs of a house. So here I have a room in a house. Before they actually built the room in real life, they had a blueprint drawing of it first. On that blueprint, one wall was 24 inches wide, the other one was 16 inches tall. Okay, but what we're told is that every 4 inches of the blueprint represents 3 feet in real life. So the way they write this scale out, and you're going to see it written like this a lot, every 4 inches is equivalent to 3 feet. They're going to write it as a ratio. Every 4 inches really represents 3 feet in real life. So there's my scale. My scale, that every 4 inches of this drawing is 3 inches in real life. So right now, the first one we have is where you have a table to break it down for you guys, and then we're going to try to do it without using a table. So if I know the blueprint's 4 inches, that's 3 feet in real life. So that means if I have 8 inches of blueprint, that's going to represent 6 feet in real life. So now we're going to count by 4 until we get to the 24 inches. So if every time I go up these 4 inches, I'm really going up another 3 feet. That's my scale. So every time I go up 4, I go up 3. So 12 inches would represent 9 feet. 16 inches, if I go up another 4 inches, which I do, I need to go up another 3 feet. So 16 inches represents 12 feet. 20 represents 15 feet, and 24 represents 18 feet. Okay, so this wall right here, instead of 24, it's 24 inches long on the blueprint, but it's really 18 feet wide in real life. The 16-inch wall on the blueprint is 16 inches long. So on real life, it is 12 feet. Okay. So let's look at another one, and we're going to look at how will we do this without a table. So if I have a game room that has a floor of 120 feet by 75 feet, so it's just a room, and I know this room, that's a bad representation of the room because it's clearly not a square. That was pretty square. So I have a rectangular game room. I know it's 75 feet. I like to draw pictures because they show me what I'm doing or what I'm working with here. And it's 120 feet wide, 75 feet. Now the scale drawing of the floor on grid paper uses a scale of 1 unit. Right here. 1 unit represents every 5 feet. Now we're saying 1 unit because on grid paper those are little boxes. So Like if you guys are thinking about like graph paper or grid paper, it's set up like this. So they're just saying that 1 unit represents 5 feet. So they're just calling it a unit because we don't know the exact measurement of that little box on the grid paper. Okay, what are the dimensions of the scale drawing? So we know 1 unit is every 5 feet. So I want to know how many units does this room go to on the scale drawing. So here's what we do. We take our scale and we set it up as a ratio or as a fraction. So 1 unit represents 5 feet. I'm going to use it as a fraction right now. Okay, and what I'm going to do is I'm going to use that and set it equivalent to another ratio of units to feet. So I'm going to keep my fraction set up the exact same way. I have units on the top over here on the left hand side where I did my scale, 1 unit. So I'm going to have units on the right, I'm going to have feet on the bottom. And I'm going to use the information that I need to find out from my scale, from my actual dimensions. So I want to know how many units are represented, am I going to need to represent the 75 feet side. So if I'm trying to figure out to get from 5 to 75, I want to know how many units I'm going to have for 75 feet. So what I did is I took my scale. So here's my scale right here. Let me switch colors here. I took my scale and I wrote it out as a ratio, as a fraction. And notice how I labeled it. Labeling it's super important because it helps you label your second fraction correctly. Okay, so we do have to label it. That's going to make us stop us from making really big mistakes. So I took my scale, set it up as a fraction, 1 unit over 5 feet. And then I made that equivalent to units over feet, again, because they have to match. I always have units in the numerator on top, feet on the bottom in the denominator. And then I'm just going to solve for one side at a time. So I have to actually do this twice. So my first, I set up 1 unit over 5 feet is equal to, I don't know how many units this is going to represent. That's what I'm trying to find. I'm trying to find the dimensions of my scale drawing. I don't know how much that is. So that's why I'm using x, because I'm using that to represent an unknown, over what I know. And I know that in real life it's 75 feet. Now from here I can solve. Okay, so from here I can solve. And this is where we cross multiply and set an equation. So what I do is I'm multiplying diagonally. 5 times x is 5 times x, which is 5x. 1 times 75 is 75. And I set them equal to one another. So notice how I set it equal. I just multiplied diagonally and set it equal to my other cross multiplication. 1 times 75. And then I get to actually solve for x by dividing by 5. These cancel. I get x equals 15. So that means I need 15 units on my scale drawing to represent this wall of 75 feet. Now notice how I only did it on one side. It asked me for the dimensions of the scale drawing. I found the dimensions of the 75 feet, but I had to do the same thing for the 120. So I'm going to use my same scale. 1 unit over 5 feet is equal to x units. I don't know how many units, that's what I'm trying to find, over 120 feet. And then I use the exact same process. So it's really 2 small, quick problems hidden into one. So now I can cross multiply. So that's 5x equals 1 times 120, which is 120. Now I get to solve for x by dividing both sides by 5. And I get x equals 24. So that means the dimension of the scale drawing is going to be 24 units by 15 units. I'm done. Okay. So, I have another one here. The art class is planning to paint a mural on an outside wall. So what they did is they used a figurative, a scale drawing, to plan out the mural before they actually blow it up onto the wall. So here's my scale drawing. Let me see if I can make this picture a little bit bigger. Ooh, I don't really think I can. There we go. So there's the scale drawing of the mural. We want to know what is the area of the actual wall. So what we need to do is I need to figure out, well, what are my dimensions of the actual wall first. So I know that in the drawing, this is 28 inches, this is 11 inches. here's my scale. Every 2 inches is equivalent to 3 feet. So let me write out my scale. I know every 2 inches of the drawing is equivalent to 3 feet in real life. So what I'm going to do right now is I'm going to write my scale out twice because I know I have to do 2 problems in order to solve. Because I know that one length is 28 inches. So that's going to go on the top because notice how we have inches on the top when I labeled it. I don't know how many feet the wall is in real life. The other side is 11 inches. So that's going to go on my numerator. I don't know how many feet that represents in real life, and that's what I'm trying to find. These are my 2 problems that I get to solve. So what we do is we do it by cross multiplying. So I multiply, that's 2 times x, which is just 2x. I set that equal to whatever I multiply going the other way. Well, this is 3 times 28. Okay, so I can write that out as 3 times 28 right now. Show that I cross multiply to set them equal to each other. Because I don't know what 3 times 28 is off the top of my head. Now off the side, I can work it out real quick. And that's going to be 84. So really my equation is 2x equals 84. Now from here I can divide by 2, and I get x equals 42. So that means the wall is really 42 feet in real life. Okay. Now I have to do the same thing down here because this is one side. This is really 42 feet. I like to draw it on the picture so I can see which side represents what. Okay, so this is 3 times 11. And this is 2 times x. So again, I'm going to have 2x equals 3 times 11. Which really 2x equals 33 feet. Divided by 2. Yes, I'm going to get a decimal, and that is okay. It is totally fine to have a decimal. And I'm going to get 16.5. So then this wall right here is really 16.5 feet. Now the question is, what we did is we found the actual dimensions of the wall. The question is, what is the area of the actual wall? So what is the area of the actual wall? So to find area, we do length times width. So now this is where I would have to go off to the side and set it up as length times width. So I would go off to the side. I'm just going to erase this right now. And I would do 16.5 times 42. Now, real quick for the sake of time, guys, I'm going to multiply in my calculator. And I got 693. So the area of the wall is 693 square feet. Okay. I want you guys to try this one on your own. Just see how you do. Try it on your own. Set up your scale first, and then find your dimensions that you need to find. So pause if you haven't paused it yet, and try this on your own. There's no harm if you get it wrong. It's okay. Just try it out. Okay, so we know that the piece is, we have the drawing. Okay, the drawing plan, we have a rectangle. I like to draw it out myself. 13 by 2 inches by 6 inches. It is important to label everything because labeling everything is how you stay organized. Because I have my scale here. So let me do the scale in blue again. My scale is, the scale on the plan is 3 inches represents 5 feet. Again, it's so important to label it because it tells you what's your numerator and what's your denominator, and that helps you set up your second fraction. Because we need to set up what our numerator and our denominator is. I know I'm going to use it twice for both sides of the wall. Well, I am given the drawing dimensions at 13.2 inches. So inches are in the numerator here. So I'm going to put inches in my numerator over here. And that means I don't know how many feet that is in real life. That's what I'm trying to find. So that equals x feet. Same thing. I got to do the same thing for the wall with 6 inches. That'd be 6 inches over x feet. Now again, just because I don't want this video to drag out forever, I am going to use my calculator to kind of help me out a little bit on the multiplication pieces. So when I solve my first wall, I have 13.2 times 5, which is 66. And then I also have 3 times x. So I have 3 times x equals 66. Now I get to divide by 3, and I would find x equals 22. So this is real 22 feet in real life. Okay, now for this one right here, this one's a little bit easier. 5 times 6 is 30. 3 times x over here is 3x. Now notice how I wrote it in a different direction. It doesn't make a difference. I did that on purpose. It doesn't matter which order you do as long as you set them equal to each other. Because now I still have to solve my equation. If I divide by 3, I still get x equals 10. So that means this wall is really 10 feet. Okay, so we found the dimensions of the wall, found the length and width of the actual studio. The length and width are 22 feet by 10 feet. And then if we want to find the area, that's the second part of the question, I would do 22 times 10, and that gives me 220 square feet. So there's the actual area. Okay, that's it. So things to remember. The big one is label units. So maybe write an example, inches to feet, or you could, I mean, it could be anything, right? You may have to write or. That's one example. I'll write an example instead of or. Another example would be, oops. Another example could be, I don't know, it could be centimeters to meters. I mean, there's a ton of scales that you're going to see. So just make sure you label it because it helps you stay set up. Whoa. Sorry for that interruption. Okay, so make sure you label everything because that's super, super important to label your units. And then also, one thing to remember is cross multiply. And we set them equal to each other. Okay, I want length, width, and area of this guy for your independent practice. Hope this video helped. Hope it wasn't too bad. Thanks for sticking through to the end. And thanks, guys. If you have any questions, let me know. Gordias out.